All right, so in this video, we're going to do several examples that relate moles to grams and grams to number of atoms or number of molecules. And the first example I would like to do simply asks, how many water molecules are there in a snowflake that weighs 10 milligrams? So we're going to assume that that snowflake is pure water. So we have 10 milligrams of water here. So this is going to be a unit conversion, and we're going to approach this problem through the unit factor method. We have 10 milligrams in our snowflake, so that's 10 milligrams of water. Now, we need to convert milligrams to grams because the molecular weights that we get from the periodic table are going to be essentially in grams per mole. So I have 1 gram for every 1,000 milligrams. So that takes care of converting milligrams to grams. Then I need to take the molecular weight of water. So the molecular weight of water is going to be 18.02 grams per mole. Another way of saying that is that 1 mole of water weighs 18.02 grams. And I get that simply by calculating the molecular mass of water. Okay, so this is the molecular mass or the molecular weight of water. It's the reciprocal of the molecular mass, so from the molecular mass of H2O. I'm putting moles on the top because I want to cancel out my grams and be left with moles, because then if I want to figure out how many water molecules I want, I'm going to need to use Avogadro's number to tell me that there are 6.022 times 10 to the 23rd molecules of H2O in every mole of H2O. And we can use this because of the definition of the mole. 1 mole of anything contains 6.022 times 10 to the 23rd units of that thing. So 1 mole of water is going to contain Avogadro's number of water molecules. And setting it up this way enables me to cancel the moles, so I'm left with what I want, which is the water molecules in the numerator here. So if you just multiply those numbers together, you should get a value of, just using 1 sig fig, 3 times 10 to the 20th water molecules. That is a huge number, right? There are 3 times 10 to the 20th water molecules in a single snowflake. So that gives you an idea of why we use moles to begin with, because counting up 3 times 10 to the 20th molecules is no trivial matter. Let's do perhaps a simpler question. How many grams does 1 water molecule weigh? So now we're going to start with the water molecule and kind of work our way towards how much it weighs. 1 water molecule we can relate to the number of moles, because we know Avogadro's number tells us that in 1 mole of water, there are going to be 6.022 times 10 to the 23rd molecules of water. Okay, because 1 mole of anything contains Avogadro's number of that thing. And that will enable us to cancel out the number of molecules and be left with moles. Then, if I want to get to grams, I can just multiply by the molecular weight of water in grams per mole. And I'm just using MOL, mole, as an abbreviation for mole. So if I multiply and then divide by Avogadro's number, I am going to be able to get a value of 3.0 times 10 to the minus 23 grams, which of course is an infinitesimally small mass. So 1 water molecule doesn't weigh very many grams at all, as predicted. Okay, let's add another layer of complexity to this. A dot of chalk on a blackboard contains 1 milligram of calcium carbonate, CaCO3. Can I figure out how many oxygen atoms are contained in that single dot of chalk? So with all of these dimensional analysis problems, I always start with what I know. I know that I have 1 milligram of calcium carbonate. Now, I probably need to convert that to grams and then go from grams to moles. So let's start by converting to grams. I have 1,000 milligrams in a gram. So that will give me grams. And I should also keep the label here. I'm talking about calcium carbonate. The reason I'm keeping that label is because eventually I want to be converting to oxygen atoms, and I want to make sure I keep track of what's what. So that's going to give me the grams of calcium carbonate. Now I need to figure out what the molecular weight of calcium carbonate is. So if you calculate the molecular mass of calcium carbonate from the periodic table, okay, and we actually did that exact one in a previous lecture, but you can go back and do that if you want. It's going to be, I'm just going to round it, about 100 grams per mole. Okay, so you can get that by looking up the atomic mass of calcium, the atomic mass of carbon, and the atomic mass of oxygen. So I can use that atomic mass, flip it over to get the reciprocal of it, to tell me that I have 100 grams of calcium carbonate in every mole of calcium carbonate. That will enable me to cancel out the grams of calcium carbonate and be left with moles. But I'm interested in the number of oxygen atoms. So looking carefully at the formula for calcium carbonate, I can see that for every 1 mole of calcium carbonate that I have, I'm going to have 3 moles of oxygen. Okay, simply because there are 3 atoms of oxygen in that formula for calcium carbonate. That enables me to cancel out the moles of CaCO3. And I want the number of oxygen atoms. So my final step is to just use Avogadro's number, because I have Avogadro's number, 6.022 times 10 to the 23rd atoms of oxygen in 1 mole of oxygen. So I can finally cancel out the moles of oxygen. And if I do all of the arithmetic here, that is going to give me 1.8 times 10 to the 19 oxygen atoms in that dot of chalk. Okay, if you divided that number by 3, you would get the number of CaCO3s, but I'm interested in the oxygen atoms here, so I needed to multiply by 3 because I have 3 units of oxygen for every 1 unit of calcium carbonate.